Hello guys, welcome back to Tronic Synergy. So in our previous video we did a connection of parallel input serial output using an IC74LS165 which is an 8-bit parallel input serial output IC, and today I'm going to show you how we can modify a parallel input parallel output using the IC that we were using in a couple of videos ago, 74LS195. I'm going to show you how we can modify a parallel input parallel output to use a single data line to be used as both the input and the output, because that's the main goal of this modification is to simplify or to use less connections, less wires to be used as the input and both as the output. So we are going to use the IC that we were using some couple of videos ago, 74LS195. And if you can remember, we said that it's a more of a general purpose IC which can do parallel input parallel output, serial in, serial out, serial input parallel output. But the last configuration, which is a parallel input serial output, after many attempts, I didn't succeed because it's quite hard. As I said, it's quite hard to modify or to manipulate the IC using external circuitry to give you such kind of output. So that's why I had to go and look for another IC which can do a parallel in, serial out, and that's why we chose a 74LS165. I was looking for a 4-bit, but the 8-bit was the one which was available, so I took the 8-bit with me to show you. So so I'm still going to use the same IC. So I'm going to explain how you can connect the 4-bit parallel in parallel out to use a single data line which is going to be used as both the input and the output. So if you can see my schematic right here, you can see my schematic. This is what I mean. So if this is a register, let's say this is the 74LS195 in a system, you can see it as a single data line. Normally you'll expect to see, if it's a parallel in parallel out, to have 4 wires as the input and 4 wires going out as the output. How the schematic or the internal schematic suggests that we have the parallel in from pin number 4 to pin number 7 and the parallel out from pin number 12 to pin number 15. So in a normal connection we expect to see 4 wires for input and 4 wires for the output. But how can we minimize the number of wires that we use, because we want our system to be more compact and to measure on the cost of production or cost of designing these circuits. So you can see here that we have a single data line which is now feeding 1101. This is just an example. You can use any other code, 1101, and it's entering the IC, which we say that we are going to use a 74LS195. You can use other ICs, but I'm going to demonstrate using this IC because it's the one which is available on me. So once you put your data in your data line, you have to activate something called the write enable. So the function of a write enable, which I'm going to show you how we're going to connect. Function of a write enable is to clear everything that was initially stored in your flip-flops. Then you can put this data in. Once you clear everything, you put your data in, and it is stored in those flip-flops. Once it is stored, when you want to extract your data, you'll have to enable the read enable. You'll have to enable the read enable. Once you enable the read enable, now these data lines which were used initially as inputs, they are going to be used as outputs. I'm going to show you the circuitry that's involved in that connection. So I hope you've understood. So if I'm feeding data into my register, I'll have to enable the write enable pin. Once I enabled it, it's going to clear what was initially stored in your flip-flops, then input the new data or the new information that you want to the new data, sorry, that you want to feed into your flip-flops. Once you have stored it, whenever when you want to read or when you want to see what is stored in your register, you will have to enable the read enable. Once you enable the read enable, these data lines are going to be used as outputs, not as inputs initially. So to modify our circuit to do such kind of connection, we have here, you can see these individual boxes are going to represent the flip-flops that we have inside, and this pin is the read enable and this pin is the write enable. So I will say that initially this is our data line. This is our data line. Let me just write A, B, C and D. So these are our data lines. So initially, let's say that we want to put our data 1101. We'll have to enable the read enable. The read enable clears everything that you have in your flip-flops, then inputs the new data that you want into your flip-flops. How can you do this in a real circuit? Or in the circuit I'm going to demonstrate as LS74195. What I've done is I've just come here. This pin number 1, which is the clear pin, is the one that we are going to use. So for the read enable, it has a push button. This switch has a push button. Rather than just connecting it directly to ground as we used to, we are going to connect it. Sorry, we are going to connect it to the power supply. Then there's a switch. Let me just try to sketch that. We have the switch right here. The switch is a push button switch like that, and right here we have connected it to this point. We have connected it to the VCC, the power supply. Okay, and this point is connected to ground. So once I push this, at that instant, then this clears everything that you have, in your flip-flops, and is ready to feed the new data that you have in from pin number 4 to pin number 7. So this is the one that I've manipulated to become the write enable pin. So once I press it, it clears everything that I have in my individual flip-flops. All of them turn to 000, and they are ready to be fed the new data that you want to feed on your flip-flops. So that's the connection. Once you've fed the data in your individual flip-flops, we have another circuit right here. You can see they are NPN bipolar junction transistors. From the output of those flip-flops to the collector, then the base, all the bases of those transistors are connected to the read enable. Then the collector of those transistors, the collector or the emitter, sorry, the emitter is taken and connected back to the input. So that we have the collector from the output of those flip-flops, base to the read enable, then the emitter back to the input of the flip-flops. So once I enable this, if I enable this, then there's a current that's going to be taking what is initially installed in the flip-flops is taken, and then this current is going to take it and it connects this back to the input. So this is going to be used as the output. I hope you can see that. If it's 1, then it finds this is on. Let's say it's on. So if this is 1 and this is on, then that current is going to come, be amplified, and is going to be taken back to the input. So this input is going to be taken as the output. The case for this one, which is a 0, that 0 is going to come. Here we have an on signal. That on signal cannot amplify a 0, so it's going to give a 0. I hope you can see that. So these input lines are going to be used as the output. So they are going to read what is stored. So 1 taking that, then goes back, it's 1. 1 comes, base, it's on, then the emitter gives a 1. The 0 comes and it gets an on signal. The on signal cannot amplify what is not there, a 0, so it's going to give a 0 automatically. Then we have a 1, it's going to come, then 1, taken back to the output. So these pins are going to be used as the outputs. So I hope you've understood that connection. These are pretty straightforward. These are pretty straightforward demonstration, but in the real connection is quite the real connection is quite complex, a bit complex to manipulate that, but it's just the same. So for the read enable, how I have connected it using my IC74LS195. You can see here we have I've just connected the transistors the way you can see. The output goes to the collector, then the emitter goes back to the input. Then I've connected this to one deep switch, which is connected, which when I want to read, then I'm going to turn this deep switch on, which is going to power all the bases of those transistors to read from still the same data lines that we are using as the inputs. So having said that, I hope you've really understood the concept of the write enable and the read enable. Remember that the write enable clears everything for you to input your data. Even logically speaking, if you want to write something, if I want to write something on this paper, like right here, I need to clear what is there in order for me to write and see what I've written. So basically that's what we are saying in these registers, because I want to feed my data into my register. I have to clear what was initially there in order to feed the new data that I want to store in my register. These two pins you cannot turn. Turning these two pins you cannot quite explain, or it's not even it's not logical to write and at the same time read. So avoid that configuration when you turn this on and turn this on at the same time, because you cannot read and write at the same time. Yeah, it's basically it. So my circuit is right here. This is my circuit. So this is the 74LS195 IC. We have the deep switches right here, where we have the 4 deep switch. These one are the data lines from pin number 4 to pin number 7 connected using these purple jumpers you can see here. Then this other deep switch, I'm just using this single switch, which is going to be the read enable. Remember the write enable, I said the connected push button switch, which is right here from pin number 1. Remember, pin number 1 is the clear pin. I've connected it to power supply via 1K resistor, then the push button to ground. So once I press this, is going to clear everything that I have on my individual flip-flops, and they're going to be turned to 0 for me to feed the new data. The transistors which we have here, NPN transistors, are right here. I'm using a BC547 transistors to do that. Then this other circuitry you can see on my right is just an NE555 in A-stable mode, which is going to function as the clock to my circuit. And as you can see, right here we have the LEDs, which are going to be used as both the inputs and the outputs via these wires. So these wires, can see, I can feed data, and at the same time I can extract data to be seen on these LEDs. Let's just do that and see. Let's do that and see what I'm saying. So let me do this. Just look for the other pin. Yeah, and turn it on. So the circuit is on. You can see the clock immediately turns on and off, and it feeds pin number 10 of our IC, which we said pin number 10 is the clock input signal. Yes. So the circuit is located. And another thing, pin number 9, I've connected it directly to ground. I just want to keep it to ground because we want our IC to behave as a parallel in parallel output. Keeping number 9 to ground enables the you can see the pin is called parallel enable, so it's going to enable the circuit to be connected in parallel input and parallel output manner. So let's put a data like what we have here in our demos, in our schematic 1101. So just keep this 1 1 then 0 then 1. So you can see there we have our data 1101, and the clock is high, so it has already stored the values in my flip-flops. But there's no way to know that until I read. So I'm going to turn this read. I've turned read on, then I turn this off, all these inputs off. You can see even when I turn the inputs off, the read is high, so the circuit remembers that you have stored 1101, and it cannot change until I clear everything that I have for me to feed the new data. So the circuit remembers that I have 1101 stored in my flip-flops, and we said the only way to overwrite everything is by pressing the write enable, which is going to clear everything that I have in my flip-flops for me to feed the new data. So I'm going to just press it. Let me just do this so that I can see. Then just like that, once you press it, it clears everything. You can see, because it clears everything that you have on your flip-flops. Now everything is set back to its initial state, and I can feed the new data. So let me just try 0110. So this is the data that we have, 0110 in our flip-flops. Because the clock is high, the data is fed into my circuitry. Then one more time I turn on the read enable. I've turned it on. Now even if I turn the inputs off, the circuit remembers that I have 0110. It reads because the read enable is on, it has 0110. It has stored, and the only way to override that is by pressing the write enable. So I turn the read enable off. Once I turn the read enable off, now the circuit is vulnerable for any change if I press this. So I press it, and it clears everything that I have on my flip-flops. Now the circuit is turned back to its initial state. Let's do that one more time. Let's do a 1001. 1 1 0 0 then 1. I don't know what's binary for 1101. I'm going to check later. So 1001 is stored in my value, is stored in my flip-flops. Then I'm going to read what I have on my flip-flops, then turn these inputs off. Then the circuit remembers that you had 1001 stored in your flip-flops. So you can extract that data. You can see that now these data lines are used as the output because they are reading what you have on your register. So 1001, you manipulate, you do what you have to do. Then when you want to feed new data on your flip-flops, you have to press the write enable. So I turn off the read enable. Turning off the read enable, the circuit becomes vulnerable if I press this. So if I press it, now the circuit turns back to its original state. So that's basically the function. That's basically what I wanted you to see. In normal circuitry or in our computers, they actually use this kind of connections because they want to minimize the number of wires that you are using for the inputs and the output. So they just use a single data line to be used as both the inputs and the output. So next time I'm going to try to connect another 74LS195, and I'm going to use this kind of configuration to connect the two 74LS195 registers, and I'm going to use a multiplexer to choose when I feed data. I want to choose which register I want it to be stored, and it's going to be quite fun. So please stick by, and yeah. So I hope you've really understood today what I wanted you to see. If you're doing this at home, just try and do it. Try to do it slowly, connect slowly, and then try to understand every step as you make the circuit. So thank you very much, guys, for watching. Please subscribe to Tronics Energy, and I hope to see you next time. Goodbye.